So this is the unit where we explore manipulating these variables with exponents. We manipulate variables and numbers inside of radicals. So basically, you're expected to express square roots and cube roots of whole numbers and the square root of a monomial algebraic expression, so like basically variables, in simplest radical forms. You're expected to evaluate expressions with square roots and cube roots. You're also expected to express square roots of whole numbers in simplest form, as well as express the cube root of whole numbers in simplest form, and express the principal square roots of monomial algebraic expressions. A lot of words, a lot of words. So what we'll be doing is essentially we'll have about 5 lessons. One of them will be multiplying exponents. Another will be looking at dividing and using the zero exponent. But first, we're just going to roll right into the warm-up and just kind of explore how we use numbers. We're going to explore factors. So a couple things you need to do here. So when you have a number by itself, it's referred to as a principal root. When we square that number, it's like saying that number times itself, okay? So if I have 2 squared, it's like saying 2 times 2. Now, what does it equal? What's the product here? It's 4. Now, if we go radical form, it's like saying the square root of 4 equals the square root of 2 times 2. We broke the number up into factors, and what happens is we're looking for the reverse of that. We're looking for one number that produces the product 4 here, one number, you can square it, and that's going to be 2. So that's a lot of words I just used. Let's try this again. So going forward, we can square 3. We end up with 3 times 3, or just 9. Going backwards, if we take the square root of 9, we're looking for 2 factors. We're looking for this number that when squared equals 9. So that number, if I break 9 up into factors, 1 goes away, 1 comes out of the radical, I'm left with 3. So let's make a little note. 1 goes away. So we have pairs. We have these pairs of factors. When we're simplifying radicals, for pairs, 1 goes away, and 1 comes out of the radical. It's a good rule to keep in mind, okay? So next, my principal root is 4, and these are in order, so I'm just going to go down and write what they are, all right? So 4 squared equals 4 times 4, and I'm just going to go ahead and square all of these numbers. 5 squared equals 5 times 5. 6 squared equals 6 times 6. 7 squared equals 7 times 7. 8 squared equals 9 times 9. And 9 squared equals, I'm sorry, I made a mistake there. 8 squared does not equal 9 times 9. 8 squared equals 8 times 8. 9 squared equals 9 times 9. 10 squared equals 10 times 10. X squared equals x times x. Now, what's the product of these numbers? Well, 4 squared, or 4 times 4, equals 16. 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. 8 squared equals 64. 9 squared equals 81. 10 squared equals 100. X squared equals x squared. All right? Now, going backwards. I have the square root of 16. It breaks down into the factors 4 times 4. When 4 goes away, the other one comes out of the radical. Square root of 25 equals the square root of 5 times 5. 1 goes away, and 1 comes out of the radical. The square root of 36 equals the square root of 6 times 6. 1 goes away, 1 comes out of the radical. You're going to have to memorize these perfect squares and these perfect radicals, okay? So here I have the square root of 49. Going backwards, this equals 7 times 7. The square root of 7 times 7 equals 7. So on and so forth. So keep going down the list. And when you get to the square root of x squared, this equals the square root of x times x. 1 goes away, and 1 comes out of the radical. Remember, you're always looking for pairs when you're dealing with squares. But when it comes to cubes, 2 go away. They are in triples. Factors are going to be in triples for cube roots. So 2 go away. And 1 comes out of the radical. So let's look at what that looks like. So 1 is my principal root. I cube 1, and I have 1 times 1 times 1. My product is 1. Now, if I'm taking the cube root, I can recognize it by the cube out front. You can also go to math, number 4, in your calculator. So the cube root is like saying the cube root of 1 is like saying the cube root of 1 times 1 times 1. Now, what did I say? 2 1s go away, and the other one comes out. So you're just going to have that one principal root left. When you're talking about triples, triple factors, 2 go away and 1 comes out. So for 2 cubed, it's like saying 2 times 2 times 2. That equals 8. So the cube root of 8, it breaks down into 3 2's. So 2 times 2 times 2. And what happens? 2 go away, and I'm left with that 1 2 coming out. Okay? For 3, I have 3 cubed equals 3 times 3 times 3. And I get 27. I take the cube root of 27, right? This equals the cube roots of 3 times 3 times 3. 2 of these 3's go away. It's a triple. And I'm left with the 3 coming out of the cube root radical. For 4, 4 cubed, 4 times 4 times 4 equals 64. So the cube root of 64, I'm looking for a triple, equals the cube root of 4 times 4 times 4. 2 go away, and 1 4 comes out. I'll leave you to do 5. But for x cubed is like saying x times x times x. So how many x's? 3 of them. So x cubed goes there. All right. So the cube root of x cubed, if I'm trying to figure out how to break these x's down, they break down to 3 parts, a triple. It's like saying x times x times x, which equals 2 going away, 1 coming out, x. Okay? Now, parts of a number raised to a power. So these are the parts of when you're working with numbers raised to an exponent. So technically this is incorrect. So the whole thing, 5 cubed, the whole thing itself, it's a power. The whole thing is a power. Now the cube is an exponent. This is an exponent. The number that is being raised to the power or of 3 is called the base. All right. Now, this over here, this is a product. So it's like saying base 5 to the 3rd power equals 125, or basically 5 times 5 times 5 equals 125. And all of these 5s are called factors. Numbers that multiply to a number are called factors. In each way, we produce the product. Okay? So what about when we're dealing with radicals? Well, on the outside, this number is called the index, or it's also sometimes referred to as a root. Okay? Now, on the inside, this number is called a radicand. And what radicals, this radical here, this is that little symbol, radical, the actual radical itself, what it produces is a factor of the number inside. So the simplest factor, simplest form actually, of this radical. Okay? So usually that's just a factor. So we're going to move on to the lesson 1 notes. And this is going to be a new video, so I'm going to stop it right there. That's just the warm-up.